Hello, biology honors. So hopefully you just watched the Bozeman science video about the chi-square test. This is my video about it. That'll be kind of a supplement to that video. I'll go over some of the most important points and give you a different way to perform the chi-squared test in a way that I actually prefer to do it versus the kind of calculation numerical way he did it. Both of them work. You can use his way or my way, but hopefully this video helps with your understanding of the chi-square test. This chi-square test will be used next week to understand our Wisconsin fast plants. We'll basically be able to compare whether what we expected to get, which is a 75% purple, 25% non-purple, is what we actually observed, or I observed in your lab data that you'll see. So let me go to my document camera here. In. There we go. My audio is still working, so that's good. So we have the chi-squared test. So first of all, what is it? Well, it allows us to compare predicted, or in the case of this test, what we call expected results to observed results. So in the case of the lab that we're building towards, our predicted or expected results come out of our Punnett square, and our observed results are what I kind of will give you in our data sheet. It goes by this fancy equation that chi squared, chi, this is the Greek letter chi, equals the sum of the observed minus the expected squared over the expected. Some of you may be have done summations in math class, some of you haven't. Hopefully I'll give you a way to be able to solve this easily in a different way than he performed in the video. But the key, before we complete a chi-squared test, we need to have what's called a null hypothesis. So we need to write a null hypothesis. The null hypothesis is what actually the chi-squared test is evaluating. It tells us whether we can accept our null hypothesis or reject it. So here is the null hypothesis that we're going to look at today, and it's the same one he looked at. There is no significant difference between the observed and expected frequencies when, this is the first one I did, when flipping a quarter. He also did the six-sided die, but that's actually a more complicated chi-square than we'll have to perform. The chi-square you'll have to perform for your lab is much closer to what this chi-square is of flipping the quarter. So what I use to solve these is a calculation table. So I'm going to make a calculation table. In this table, it's going to kind of set up like this. The top of your table are going to be your two options. Is it heads or is it tails? Is it purple stem or is it non-purple stem in the case of the lab we're going towards? What's our observed results? What's our expected results? What's our observed minus expected? Notice this is part of this. What's our observed minus expected squared? And finally, what's our observed minus expected squared divided by e? So this is a calculation table. It'll take us through each part of this to give us a chi-square value. So let's run through it. When he flipped his coin 50 times, he got 28 heads and 22 tails. Well, what do we expect? Well, it's flipping a coin. We expect if we do it 50 times, 25 of them to be heads and 25 to be tails. So our 50-50 shot. So in our calculation, we'll now go O minus E. 28 minus 25 is 3. O minus E, negative 3. O minus E squared, so 9 squared, 3 squared is 9. Negative 3 squared is 9. And finally, 9 divided by what we expected, 25. 9 divided by 25 is 0.36. 0.36, because this is also 9 divided by 25. And then we add them together to get a chi-square value, our chi-square value of 0.72. We have to compare that chi-square value to what we call the critical value. The critical value that you need to be aware of is 3.841. If your chi-squared value is below your critical value, you're going to accept the statement that there is no significant difference between the observed and expected frequencies. That's good. But if you're above it, you're going to have to reject this statement. There's something going on crazy with this quarter, but that's kind of all we can say. So in this case, we are well below our critical value. We're 0.72, well below 3.841. So we are going to, just like in the video, we're going to accept this null hypothesis. That, yeah, this quarter is just like it should. Those observed results are close enough, statistically speaking, to what we expected. And we're going to do a similar thing next week with our chi-square, our Wisconsin Fast Plant Lab, where you'll be writing your own null hypothesis and then testing it, whether you're going to accept or reject that statement. That's where we're going. Hopefully this video is a little bit different, maybe looks at it in a slightly way that makes more sense to you or maybe less sense to you, but you have something else to kind of work with